Now we're going to try and do the reverse process. That is, given an adjacency matrix, we're going to try and draw a network that matches it. You really should first of all decide whether or not you've got a directed network. Now if this matrix has got a symmetry, then we know that it's an undirected network. If it's got the thing where row A is the same thing as column A. Row A is 0, 2, 1, 1, 0. Column A 0, 2, 1, 1, 0. Now it's the same for any other row. Row C is 1, 0, 0, 1, 1. Column C 1, 0, 0, 1, 1. They match throughout the whole matrix. Therefore, it's a good indication that this matrix is an undirected matrix. We needn't worry about having arrows on things. So let's start by drawing it. Now there are 5 different vertices in the network, so let's put them down. A and B, C and D, and E, and we'll see if we can connect them up. Now there are 2 edges from A to B. So from A to B there are 2 edges, and obviously if you look around the other way, from B to A there are 2 edges, so there's no need to indicate these with arrows at this stage. That'll work itself out. From A to C there is an edge. From A to D there is an edge, but that's all from A. From B there is 2 to A, we've already done that, and there is 1 to D, but no others. From C there is an edge to A, we've already got it. There is an edge to D and 1 to E, an edge to D and 1 to E, but no others. From D there are edges to A, B and C, and also E. From D there are edges to A, B and C, and also to E, so I'll put one in around there. And from E there are edges to C and D. From C and D, we've got them already, so there's our network there. Let's have a go at the next one. Now with this one, if you have a look at it, you'll see a lack of symmetry. Row A is not the same thing as column A, and you'll find the similar throughout the rest of it. So for that reason, this is likely to be a directed network. So we'll indicate things with arrows. Let's put down some points. Okay, so from A there is an edge to B. I'm going to indicate it with an arrow this time because I know I'm dealing with a directed network. There is also an edge to E. But you'll see there's not necessarily an edge from E to A, so that's why the arrows are working here. From B there are edges to C and to E. So from B to C there is an edge, and also from B to E an edge. From C there are edges to both D and E, but none others. From D there are edges to A and E. Now that one to A I'm going to put around here like this. And one to E. And from E there are no edges to anywhere else. E is what you would call a sink. It's got edges which come into it, none which come from it. Now, a couple of little things about these. You may find that you have drawn a completely different network to your classmate, but it doesn't mean that either you or they are wrong. You can have alternative networks which both mean the same sort of thing. They're what we call topologically equivalent, even though they may look a little different. The other thing you'll find is this. Now, I actually had a bit of a go of this on a bit of scrap paper before I turned the video on. And my first network I drew was actually pretty messy. It had lots of lines crossing over each other and that sort of thing, and it was difficult to read. So I found by rearranging the points on the page, it looked like here I put them down just at random, but actually I had thought about it. I designed where they were meant to go. And you might find if your first network's looking a bit messy, and you might find, if I get point C and I move it from here and I move it over there, the whole thing's going to be a bit easier. And so sometimes it might take you a couple of goes just to neaten up your network just a little bit. See how you go.